Perfect. So let's start, and we hope that Jacques can connect in the meantime. So hello, everyone. Welcome to this webinar. It's the first time I have the pleasure to host a webinar myself. So I hope all the webinar logistics is going to work just fine. So the objective today is, as you know, Intermarché, which is one of the, I would say, biggest French retailer, organized a forecasting competition, I think, over the last 2 months. And we have the pleasure today to have with us 4 of the top competitors that they will explain us how they did it, how they saw the data set, what kind of models they created, and how well they work. Before we start, we're going to spend so much time discussing the models and the solution, and you will have the opportunity to ask them all your questions. Just before we start, I would like to introduce everyone on the panel here, and then I will take a few minutes to introduce the competition to you so you have a clue on what the data set was like, what was the objective, and I will also give my opinion about the challenge itself in terms of is it relevant to supply chain. Just to introduce the team, maybe let's start with Florian. Would you mind to just quickly introduce yourself?
Yeah, sure. So hi guys, my name is Florian. Again, sorry for my English accent. French guy have bad English accent, but this is the way. I am a math and IT engineer at first. I have founded Prevision.io, so some of you may know or not the company. We are an enterprise AI platform with a very strong automated machine learning capabilities, and also a model marketplace that we provide to our customers. And I have been in the business for a couple of years. Back in the day, I still am, but a Kaggle master. I write in R. I guess I'm the only guy in the top 10 of this competition not writing in Python, but we can do it. I mean, you just wrapper above some XGBoost or other algorithm. And feel free to pick me on LinkedIn or shoot me an email if you want more information about me, about the company, especially or about the challenge. I would be glad to give you some answers.
Perfect, thanks. Raphael?
Hi everyone. So my name is Raphael Sourty. I'm a student actually. I'm a student at the University of Toulouse, and I work for Renault. So I'm working on NLP and knowledge graph, and also I love machine learning, so time series and a lot of other subjects, and deploying model into production, stuff like that.
Amazing. I'm glad we have a student as well. So for people listening to this, if you follow the M5 forecasting competition from 2020, the winner was a student. So it's really the proof that with new ideas, you can really make amazing forecasting model. Finally, Dan.
Hi, my name is Dan Emery. I'm based in the United States, so sorry about my super American accent. I'm a senior data scientist at Coupa. Coupa is kind of a cloud platform for a variety of different technologies. My job there is generally managing SQL databases, with maybe 10% of my code writing being Python. Outside of work, I love writing Python code, and I'm always doing some sort of data science competition. I started out my data science journey on Kaggle, like I think a lot of other people. And then I've also competed occasionally on Driven Data, which is more of a data science for good site. And then I spend most of my time on a competitive site called Numer.ai now, which is more of like an automated hedge fund, automated machine learning based hedge fund, which is really cool. But yeah, if you have any questions about my solution after, feel free to reach out to my email or my LinkedIn.
Great, thank you, Dan. So finally, myself, Nicolas, I guess most of you know me. I simply like to introduce myself as someone who's genuinely interested and passionate about inventory optimization and forecasting. I do a lot of things about that, as you mostly know by now. I'm a consultant, coach, trainer. I teach in a few universities, and I also publish books. What else can I say? Maybe something no one is aware of. In the past, before being interested in forecasting inventory and teaching that, I used to teach people how to dance. It was kind of very different, and I guess very difficult to organize webinar about that. Anyway, let's start with the competition. I do not see Jacques on the webinar. Unfortunately, I hope he'll be able to join soon. Let's start here. So let me quickly describe in just 2 slides the competition so that you know what we're gonna discuss. So up, as said, Intermarché is one of the biggest French retailer, and they made a competition where the objective was to forecast 90 days of sales from 1st of Jan 2019 till the end of March, not January, but March. What's great about this competition, and it's something I loved, is that you need to create a forecast per product, per store, per day. I think it's extremely relevant for supply chain today. In the setup of a retailer, you need to know your sales per day, per product, per store, right? Now, maybe another word about this. I like to compare that to so many supply chain that still are sticking to, let's do a forecast per month, because we always did monthly forecast per country. So we're gonna stick to monthly forecasting per country. In this very specific case here, I think we are looking at the right aggregation level, and I'm really glad we have this. On the other side, how do we measure the best forecast? On this competition, we use a very specific metric. We'll discuss more about it, but the metric is the root mean squared logarithmic error. So pay attention here that we have a L, so it's the RMSE-LE. It's a very unusual metric. I'll just discuss about it in 2 minutes. There is another thing that's kind of special for this competition, is that we only had 1 year of historical data to make a forecast. Due to the fact that we only had 1 year, it's extremely difficult to understand seasonality, because you only have one Christmas, 1 New Year, and so on, 1 July holiday, and so on. So it's very, very difficult on this data set to understand any seasonality, because you only have 1 year. Typically, when you do a forecasting project, when I do that with clients, you have 2, 3, 4, 5, 6 years of data. Something else that was a bit missing in this competition was the fact that there was no weighting of the product, in the sense that in a supermarket, as you can imagine, you have a few products that are worth like 15 cents, and you have a few products that are worth 20 euros. Obviously, when you do a forecast, you just want to have these 20 euro products, right? And if you get a bit wrong with these products that are worth just a few cents, it's not a big deal. In this competition, every single item was treated absolutely equally. So it means that you get rewarded if you get these high volume, low value item. Just to give you a few hints about the data set. So we had 2,500 products. We had a few info about the product, but not so much, like kind of categories. We had 150 stores. Again, we had a few information about the stores, like what kind of store is it, how big is it, how many checkouts you have in the store, and so on. Now, if you did the math, if we have 2,500 products and we have 150 stores, you have a total of 100,000 unique combination. So this data set is really massive, with 280,000 unique combination to forecast. If you compare this against the M5 competition from 2020, it's, I think, 5 or 6 times bigger. So it's really a massive competition in terms of data. It's much, much bigger than M5 from last year. We also get as a data the price range. That's awesome, I think. We just missed something, is what I call historical stockout. So we got sales per day, but maybe in the data set you could see some missing values, and we don't really know, did we miss sales because there was a stockout and nothing was no stock was available in the supermarket, or did we miss the data simply because it was not for sale on this specific day? So I think this kind of data was a bit missing. Now let me just discuss, before we look at the solution, this very strange metric, this RMSLE, so the logarithmic squared error. So you have the formula here, and I made a small graph here on the right, as you can see. So on the right, I'm showing you like the impact of this metric if you forecast an item with a demand of 100. So let me explain that. So let's imagine you sold 100 pieces. Here's the error you would get based on your forecast. Obviously, if you forecast 100, you get an error of 0, bravo, everything's fine. Now, as you can see, it's a very weird KPI that's totally skewed. So if you under forecast, you get a very high penalty. As you can see, if you forecasted 20 pieces, you get a very high penalty. On the other hand, if you over forecast, the penalty is very low. So it means that it rewards you from over forecasting. In doubt, it's much better to forecast 10% too much than 10% too little. One of the issues of this metric in real life is that it's extremely, if not absolutely impossible to interpret by management, and that's why I would not advise to use it. On the other hand, it's also biased, and I hate biased metrics. If some of you are thinking, well, Nicolas, but maybe it's a good idea because over forecasting is not such a big deal and under forecasting is bad, so we should promote over forecasting, I would reply, let's not do that in the forecasting metric, let's do that in the inventory optimization model. Finally, if you use RMSLE, you will not be able to weight each product by its value, because weighting the product by its value, knowing that you take the logarithm of the demand, will make a very weird metric. And I think it's really a pity. Again, in supply chain, you have some high value item and some low value item, and you want to weight these so that you focus on the items that are worth the most money. That's what I just said. And finally, again, if you're afraid of shortages, instead of taking a skewed metric, I would really advise you, let's work on inventory policies rather than the metric. So to recap, this is a massive data competition with so many SKUs at a daily aggregation level. So in terms of data, this is massive. But on the other hand, I have some doubts about the metric, that I think that this very specific metric will not be used in practice for real supply chain. That's it for me for the intro. I will now leave the floor to, I think Florian is the first one. Florian, will you share the screen?
Yeah, I can try.
Perfect.
Okay, hope you see it. Do you? Yeah, okay, fine. So thanks again for this webinar. I'm not going to introduce myself another time, but let's move on. So first thing, disclaimer, my solution is not the most hardcore one. So don't expect new age data science here, just proven stuff that has been well working in this competition, but no LSTM or really tricky stuff involved in this solution. The first thing I want to tell you is that I did use very almost common hardware, nothing about cloud computing involved here. So I use my personal laptop, okay, which has enough inside, but we don't care. Only 16 gigs of RAM. So we care a lot about that, because we'll see that because of the volumetry, I had to make some design in order to fit my memory limitation. And again, I'm working on Windows with R, so you can do it. No need to be always on Python. Both work very well. And here is the list of packages I have used. So Ranger for random forest stuff. Random forest, you will see, did work well. And the classical XGBoost like JBM stuff that works on every competition always. So maybe before going deep in the competition, the first thing I can tell to competitors is that please do not go blind in the competition. We have some insight given by the organizer. So the documentation gives you information, typically rules, metric, like the RMSLE is very important and will lead to some design in the resolution. That is important. How the evaluation criteria is, typically how is a test set designed, is there a shift between public and a private ladder board that sometimes you can see on competition. Here it was not the case. So to be fair, it offers some overfitting capabilities to competitors that can have been exploited by some of them. But well, this is the same for every one of us. And again, take a little time to make very basic exploratory data analysis. I'm not a huge fan of big EDAs that some data scientists like to do, but again, understanding the volumetry of what we're working on, how many products, chop, stuff like that, number of rows, column available in the different data sets, and also the target distribution. This is very important. And because when you look at that, you see that there is one problem, is that we have always at least one product sold. And in reality, that's not the case. Typically, some products are non-sold on some days. So this is a huge warning, because if you take the trained data set and you learn a model on that, you will learn that there is always one product sold, which is not true. So you have to think about how to provide to the model a representation of non-sold items. So my approach was very stupid. I mean, for every product cross-chopped, so typically a cross-join between the data, everything that is not in the dataset provided will be set to 0. Maybe it's right, maybe it's wrong, I don't know. But it is the design I have done, and this will expand the dataset from 13 million rows to more than 100 million rows with a lot of 0 inside that. Typically, like said in the introduction, the target distribution is heavily skewed. Like we said, like 70% are 0, so non-sold item, and a third of non-zero value is exactly 1. So a main challenge will be, in fact, try to predict if a product will be sold 1 time or not, and if yes, how many times. Again, since we're working on RMSLE, you don't need to, but it's common sense to transform the target to log of the target +1 because I have introduced 0 quantity, and obviously log the 0 is not well defined. So target will be set to log the target +1. And then you can optimize RMSE on this new target. In fact, you will be optimizing RMSLE on the raw data. Okay, about feature engineering. So, you know, when you're doing a machine learning competition or machine learning project, you have to start from raw data that were provided by the organizer, and you have to make some transformation based on that. Again, my one was pretty stupid, but let's go inside. I have transformed price and some information about shops that were textual, categorical, but represented by text into ordinal feature in order to ease the understanding from the algorithm. Not well necessary, but still something to do. Some extraction of date feature information like day, month, year, quarter, but typically weekdays, there is huge discrepancies between typically Saturday and Sunday versus the rest of the week. And I also added special days information. So the organizer said that you can add holidays or stuff like that in the dataset since it's public data available. It was not really interesting, but I did it. So I communicate to you. And by then, just merging everything into a single data frame. So nothing fancy, but you make one training dataset available with around like 20 features, if I remember correctly. By then, I have created some business feature engineering, and this one was really needed in order to ease the understanding of the algorithm. So typically, like I said, you have huge variation by products being sold by day of week. So please also remind you that we were evaluated 1 quarter ahead. That means the evaluation test set was on the first quarter on 2019. And what I have done in order to help the algorithm to understand that is that I have compute aggregation function like the mean, max, and standard deviation of product. So sort by quarter, shop, articles, and weekdays. And then I have offset this information by 1 semester. In fact, I just lag information about 1 semester and then join back the information on the original data set. That will lead to something not really cool is that the first trimester of 2018 won't have information. So you will have always missing values on aggregation because it's not defined the semester prior to that. We only had 1 year of historical data. So just set missing values to -1 and you're good to go. So once you have done this feature engineering, maybe you have to think about how to design your test set creation. It's not common for data science competition to have missing test sets, not provided by the organizer. So you have to think about that. My logic was exactly the same as my trend set. So just expanded for every day's product and shop. You make the cross join of that. So you have a huge test set being generated. I have cropped it with, price that are available on the Q1 2019. No need to keep products that don't have price in the information system. So it crops a little the test set. And by then you can make the modelization since you have the train and the data set. So, like I said, since I'm working on my commodity hardware, huge number of rows, like, I don't know, it was maybe 120 million of rows. So can't make it fit on my computer with standard algorithm. So what I've done is pretty straightforward, is that I have made 149 models by shop. So every shop has been learned differently, shop by shop in a loop. I mean, nothing crazy. You learn by the shop on the expanded train set. You predict on the test set from the shop. And my approach on the modeling was fitting different algorithm family. So I have fit a random forest, which interestingly score the best for me. And that illustrates that there is a lot of noise in the data set, in fact, and also that maybe my validation strategy was not the best one, but a single random forest done 149 times was scoring on the 40th place, so that was okay-ish. And then I have done the same for light GBM and 1 boost that were a little bit worse, to be fair, but then I have just made an average prediction of 2 times the random forest because it was the best for me, plus the light GBM, plus the EG boost. And then that was almost my contribution. Remind you that since we are working on the log of the target +1, you have to roll back to the original target. So you may take the exponential value of the target -1. And a little trick on the post-processing of that quantity, remind you that we have to provide an integer, okay? And this quantity is not always an integer. So what I have done is that for every product that was behind 0.4 in the prediction phase, I cast that to 0. And between 0.4 and 0.55, I cast that to 1. And this illustrates what Nicolas said in the introduction. Over forecasting is okay-ish for this competition. And again, splitting the null versus 1 value was one of the main topic of it. And I have found that this threshold was a good one. And for the other one, just run the target. And by then you drop every prediction that is strictly inferior to 1. I also dropped a prediction from the 1st of January. It was kind of tricky, but I guess a lot of shops are closed at this date, so don't bother with it. Close that and remove prediction. And the same was done for some shop that used to be always closed on classical Sundays on 2018. I have made a list of that and just again cropped prediction. It was a minor improve, but again, when you're doing competition, every improve you can take, you like it. And that's it. Nothing crazy. I hope you get it. If you have any question, I guess at the end of the...
Thank you so much, Florian. I totally recognize the trick you did of removing the sales for 1st of Jan and so on. I use the same kind of idea. It's very smart, and I love it because it's kind of very easy idea that you can discuss with business people, saying, you know what, on Sundays there is no sales, and just this improve your accuracy by a small %. Okay, thank you. So who's the next one to present? I cannot remember.
It's me. Can you guys hear me all right?
Yeah.
Perfect.
Okay. Let me share my screen. Where's present here?
You have to click the present button.
Yeah, there it is. All right, and you guys can all see this fine? Cool. So yeah, getting started. So this will be the 5th place solution to the competition. I'll say one of the things that I feel like I need to address before I even get started is what were really my motivations in competing here. Being located in the United States, I wasn't prize eligible, but I think something that I have and something that everyone on this panel has is kind of a passion for forecasting and data science competitions. So coming across a good forecasting competition is pretty rare. So I jumped at the opportunity anyway. So I actually had 2 more personal goals on this competition. The first of which was to just completely ignore the leaderboard. I'll say that I wasn't exactly successful in this because obviously if you look at the leaderboard and you're near the top, you want to be the top. But I did my best to not look at it too much throughout the competition. But reading through a lot of previous winning solutions on Kaggle or whatever M4 or M5 competitions there are, I decided I wanted to try to build 5 models that were robust, scalable, and high performing, so that they would not only perform well in this competition, but if I were to do a different competition or bring something back to the workplace, I could use the learnings that I have from this competition on that problem. So what I eventually identified is that I wanted to build a convolutional neural network, a sequence-to-sequence recurrent neural network, and a feed-forward neural network. All 3 of these operate on similar mechanics, although the feed-forward neural network is more statistics-based, while the CNN and the RNN are more sequentially based. And then I wanted to build 2 light GBM models. One of them was a day-by-day light GBM model. That means that it predicts 1 day at a time. So with a forecast horizon of 90 days, that means I'm building 90 light GBM models. That one took a little bit long to run. And then finally, a global light GBM model. This is actually a little bit similar to Florian's solution here, where I shifted volume by a quarter in order to get it to predict each day at a time with one model. And you can see from the scores and the ranks that in the end, I had 5 models, which all independently would have placed in the top 20. My final solution was a combination of just 3 of these models. My favorite model was the convolutional neural network. I think it's my favorite because it does the feature engineering for me. I feed in the raw sequence, the mean for the item sequence, the mean for the stores sequence, and then some price features, calendar features, and categorical embedding features. And then because I'm not maybe the most creative person when it comes to feature engineering, I like this approach because it's really easy to just change. There's less things to change when creating features, I guess. The feed-forward neural network is based on rolling statistics. We do mean, min, max, variance, etc. For the SKU level, the item level, and the store level, as well as the categorical features. And these were my 2 highest performing models independently. My sequence-to-sequence RNN was also fairly high performing, but it took about 5 hours to train, so I didn't really like using it all that much. And then my light GBM was pretty straightforward and simple. And my final solution ended up being a just weighted average. I did not tune this blend very much. I just kind of randomly picked numbers to multiply each prediction by, so that it matched up with what the leaderboard was kind of showing me and my local validation was showing me. So speaking of the validation, I want to urge that this is probably one of the most important things in setting up when beginning any data science competition. For a forecasting competition, I always have a bias towards a walk forward validation structure. This is where you encode and build all of your features before a certain time, and then you predict the next 90 days, and then you simply move all of your SKUs forward the next 90 days and then do the same operation to validate your model. With this competition in particular, the last quarter had a lot of outliers, so it made validation incredibly difficult. I had a gap between my local validation and the leaderboard throughout the entire competition, but I always focused more on improving my own validation statistics than I did the leaderboard, because that's what you would see in the real world. So next I want to commit a cardinal sin of data science and use an Excel graph, but this is just monitoring my scores throughout the competition. And I'll keep coming back to this graph and annotate it as I go through it and show where my biggest improvements came, because I feel that a lot of times, hearing that you're using a recurrent neural network or a convolutional neural network gets pedantic and intimidating, but even using those models, it's still simple data science, simple observations that yield the biggest results. So yeah, don't hear that and think that it's an overly complicated solution, I guess. So like all of the competitors here, I'm sure I applied a log transformation when reading in the data with root mean squared log error. Obviously, you want to optimize the metric that you're you're using in the competition. So I also applied a logarithmic transform to all of the demand. I also filled the missing data. So the way the data was presented to us in the training data set, if there was no sales on a particular date, it was left out of the training data. I was able to fill all of the data with zeros by simply pivoting the data, which you can't always do. But in this case you could, because there was all 365 days were recorded at least. And then when I come back to that graph, just doing these simple transformations, I was able to start to develop my pipeline. So if we start on the left, I began with a series of baseline models, your naive. I was trying like yearly naive, quarterly naive, and moving averages. Also trying some post-processing steps. This is where I learned that if you fill January 1st with 0, you can improve your score by a pretty good amount. And then from there, I began development of my machine learning models. But when developing my machine learning models, I quickly realized I wasn't really optimizing the competition metric. So coming back and looking at the rules, I'll read a quote from the rules, although it was translated via Google, so I don't know how great the quote will be, but it's saying that the evaluation only applies to expected predictions, for example, where there's at least one real sale that's been recorded on the same day or the previous 6 days. So what that means is, of course, all non-zero values are scored, but when you look at a 0 value, that breaks down into either a scored 0 value or an unscored 0 value. So if there's been no sales in the last 6 days and it's also 0, that 0 does not factor into your final score. So what I did from this was I developed a way to identify these scored and unscored zeros. It's really, you can do this by calculating a rolling sum per skew. And then if that rolling sum is greater than 0 over the last 7 days, then that means that value is going to be scored. I then incremented my entire data set by a factor of natural log of 2 over 2. And what this does is, I only incremented the values that are scored by natural log of 2 over 2. And what this does is it means that any value that's 0 in your training data set now will not be scored, and any value that's non-zero is scored. The reason I did this was because I had the intent to build my own loss function here. This is really just root mean squared error as a loss function. However, you can see that I have one condition, and it's where y true does not equal 0. So that means it's not optimizing anything when y true is equals 0. If we come back to my timeline here, when I first started developing my machine learning models, I was hanging around a score of about 0.58. And then by the time I was completed implementing my custom loss function and debugged all of my issues, I had a score of about 0.56. So really big improvement just through understanding the competition metric and tuning the model to what the competition wants me to tune it to. After doing these 3 translations of the data, I applied the same practice to each of my models. So I did the same thing with my feed-forward neural network, and I did the same thing with my light GBM model. I then just created an ensemble of those 3, and that would have landed me in 8th. I had a general belief that I was under-predicting values throughout the entire competition. This is because it's not really accounting for generalized supply chain problems, like stockouts and inventory problems. So I wanted to, throughout the entire competition, build a model which predicted this trend correctly, but I didn't believe that I ever did it. So at the very end, I just multiplied my predictions by 1.04. This is something that I learned on my model validation, and that moved me into 5th. And it was actually my very last prediction. It was something that I didn't want to do throughout the entire competition. I didn't want to apply post-processing, and I wanted to ignore the leaderboard, but in the end, my hubris got the best of me, and I wanted to climb the leaderboard, so I applied this post-processing. But it did greatly improve my model, and I think it was just a lazy way of covering something that maybe my model did not cover. So that's it for mine.
Thank you so much. And I love this graph. If you can just show it just 1 more minute, I think it's super interesting. And I would like to add something on this amazing graph you've made with your improvement through time. Can you share it once again? So
Yeah.
can you show like 2 slides before where you show the different models you created? Yeah, can you a bit up when you show your benchmark? I think that's a very interesting things to learn for supply chain people. When you start this kind of forecasting model, what I always advise is start with a very simple benchmark, like a moving average or a seasonal moving average. As Florian explained, and you did for sure as well, you can improve this benchmark slightly by saying, well, on 1st of January, you have no sales. On Sunday, you have no sales. Let's just do that, and you already have a benchmark that's quite good. So in this project, I think I should write an article about it. I didn't do it yet. I was able to reach, I think, a score of 0.595 that was beating 50% of the competitors just by doing a good moving average with just like no sales on 1st of January. So just by doing this very simple benchmark, you could already beat 50% of people. What I love here is that you really show that you started with something simple and then you invested time to tweak it and to go really and to push it. And obviously everything you did is really like best in class with your custom loss function and so on. It's amazing. Thank you so much, Dan. So I think now it's up to Raphael to show his solution.
Yes. So I share my screen. Do you see my slide? Yes?
Yes.
Do you hear me? Yes, okay. Okay, so I'm going to present the fourth solution on the leaderboard. So my solution is pretty simple, is mainly based on the pre-processing of my data. So here I represented the data that Intermarché gives us as a calendar. So as you can see, they are for some days recorded sales, and for other days no recorded sales. So we can assume that when we do not have recorded sales, that it's a 0. I created a rule which says that when we do not have any recorded sales, it does not mean that we should tell our model that there is a 0, for example. So here I created the artificial data here just to say that, for example, the first week of January for this specific item and this specific store, maybe it's not a sell. The store may be closed, or the item is not in reserve, and it really improved my model, the signal I gave to my model to put a simple rule. So basically, my rule is after a recorded sale, you can add up to 50. And if you do not record any sales for up to 5 days, you just have to consider that the product is no longer on sale. So here I just represent two statistics, two aggregates. So mean sales per days of the week without my row. So basically, when you fill all missing value with 0. So as you can see, those aggregates underestimates the real sales. So it say here on Sunday that it's 17.5, but actually, if you consider that the store is not open on the first week, it's more about 23. So here it's my aggregates with my rule. So basically, this simple rule allow me to do not overfit, and gives a good signal to my model. It allow me to replace the target encoding that I used by a simple min encoding. So I recommend a great post blog by Max Alford on target encoding, which explain the concept, and that's pretty all. After having pre-processed and trying to adjust this rule, I just created a few features, such as aggregates per item and store, aggregates and price, and some other. Also, rolling aggregates, so gives information about the near past, help my model. I apply a logarithm on my target variable as everyone, and I just fit a single model using a cross validation with bagging. So I assume maybe everyone know what is bagging, but bagging is just a way to make an ensemble of model easily. When you do cross validation, you split your data in k parts. So here it's in 3 parts, and you can train a model on each of these parts. And bagging is just about averaging the k model you train on the cross validation. Also, I put some rules to avoid predicting too much when there is not enough data available. And my solution, run in a bit more than an hour on my personal laptop with 16 GB of RAM. I think my solution is a great baseline for a production deployment because it's with a single model and not too much features. And I like Treelight, the library Treelight, to compile LightGBM in C to speed up the model for inference. And so my code is available on GitHub, so feel free to check it out, and also feel free to send me an email or connect on LinkedIn if you want to discuss, or if you have any question. Thank you.
Thank you so much, Raphael. So I just as a reminder for anyone that didn't hear the intro, you are still a student, which is really amazing that you could achieve this without, I would say, so much experience as a demand forecaster or a data scientist. So it's really amazing. Thank you so much, Raphael, for this explanation. Jacques, then your turn for the last presentation. In the meanwhile, in the meantime, for the people attending the webinar, you can ask your question. We are answering what we can. So feel free just to ask the question in the chat, and we can have then at the end of the discussion a few minutes of exchange. So Jacques, the floor is yours.
Yes, hey everyone. Sorry for being late. I did a mistake. Thank you for inviting me. I was hearing you, so really interesting, and I think it's going to be a bit easier for me because some concepts were introduced by all of you before. So I'm Jacques Peeters. I finished third for the competition. I was first at some point, but yeah, I was really close, so a bit disappointed. But let's discuss about the challenge now. So this is a plan. I'm not sure that I'm going to deep dive inside each spot because I only have 10 minutes. So I might go a bit fast on some part, but that's a game. So about me really quickly, I'm lead data scientist, a machine learning engineer at ManoMano. I'm going to speak really quickly about ManoMano. I learned large-scale machine learning in production at ManoMano. Work on a wide variety of topics like recommender system, cost per click models. I'm also working the sales forecasting we are the warehouse and we need to forecast the activity. It was really tricky because during COVID, it's a new service, so we lack of historical data. But about my story is that I was not really passionate at school with what I was doing. Even so, I was studying statistics and computer science, but I started to get really involved when I started practicing on Kaggle. And this is where I learned a lot of things and I had some success. So I'm not the best one, but I even won some money at some point. Already about quickly Mano Mano to give you an idea of what company I'm working at. This is an European marketplace for do-it-yourself improvement and gardening. We did more than 1 billion business volume last year. We were valued like more than 2 billions a few days ago, so we are a unicorn. The company is growing really fast, so things are moving, and we have 10 minutes products. So when you are trying to do forecasts of 10 minutes product, you have like big data problems. So what's a good mindset to approach a machine learning competition? Actually, the good mindset is to approach it not for competition, but for general machine learning problems. What I do is that I just try to apply smart rules done by smarter people than me. This is a really good advice given by Google. So if you did not read it yet, I strongly advise to do it. So do machine learning like the great engineer you are, not like the great machine learning expert you aren't. Most of the problem you are going to face are in fact engineering problem, and most of the game comes from great features, not great machine algorithms. Make sure your pipeline work. Start with a reasonable objective. Add common sense features in a simple way. Make sure that your pipeline stays solid. So what does it mean in competition? If we adapt to little things, the first thing you want to do is to start simple. You want to be able to check that your code is working and you are able to submit to make a submission. Then the objective is given here. This is a root mean log square error. So we are just going to try to optimize this. And over time, we are going to complexify your pipeline. This is what Dan was also doing, but we are going to add more and more features over time. And so for fourth principle is that you want to keep iterating, always have something to be working and increment the complexity of your solution over time. So let's deep dive about feature engineering. This is my main data set. Maybe it's slightly different from what the other competitors is doing. This is, I'm referring to the date of the origin. This is the date of the forecast, and the date of the destination. This is the date forecasted. And this is the store we are forecasted on the article, and we have horizon here. So if we are adding the horizon to the date origin, we get the date destination, the quantities, and the log value. As Florian was describing, I also heavily rely on various feature engineering. I'm copying like mean, median, quantity, standard deviation on multiple variables. The quantity is a log quantity for different granularities, like for the store on the article, but also for the store and for the articles on day of the week. And I'm creating a lot of different features. For example, for on one day, on more than 100 days. And I'm going to feed all these features to the algorithms, and I'm going to let him decide what's the best features. We only add, I also created like a features which is the seasonality, weekly seasonality of each categories. For example, what the idea here is that maybe we're selling more wine on Friday than chicken on Friday, and I'm going to feed this seasonality, this weekly pattern to the algorithms, and I'm going to let him infer or tweak, is it useful or not? So this is the main features. I also added other features like, is it holidays or on the distance to holidays day to holidays? So it's a bit tricky. I'm going to be fast because I don't have much time. Yearly seasonality, we only have 1 year of data, but I was trying to still take this into account if we were experiencing yearly seasonality. The idea is that maybe, let's say we are selling swimming pool like at Mano. We know that if we are trying to predict the sale in July from May, that we're going to have an increase of sale of 25%. And we want to give this increase to the model and let him infer, okay, this is a expected growth or expected decrease in the sale. So for example, when you start from the week the week number 28 and you go to the week 24, the expected growth is like 5%. And I was trying to give this, I'm overfitting because I only have 1 year of data, but I was trying to help the model with these features, but actually it did not work well for me, but this is what I was trying. I also tried to to get features like what was the average price previously, and do we have like change in the price, and also give these features to the model. So we have, and what I'm speaking here is that I'm add a lot of different feature engineering, and things get messy really quickly. So it might be difficult to handle this and keep a good pipeline. So I'm going to market a little bit, because I will talk about how to approach to scale feature engineering, how to make things a bit cleaner. If you want, have a look at this. Yeah, so it's all about, at the end, you have a lot of different feature engineering, and you are going to join everything together. About metric optimization, well, just read the rules and apply them blindly in a way. So as other competitors already defined, you need to transform the target to optimize the metric. You need, some lines are not evaluated. For example, product without sales during 7 consecutive days are not evaluated. So you need to remove this line from the training data sets. Why the organizer that did this is because I think they don't have explicitly out of stock information. So you don't want your model to learn to predict out of stock, because if you create a forecasting algorithms, you want to forecast and avoid out of stock. But if you try to predict out of stock, actually you are going to learn to out of stock and not to avoid out of stock. So I think this is why they did it. And as Florian was describing, you need to run to integers. So I did something a bit smartly in a way. I was computing the, you either want to sale or float to integers of float prediction, but I was computing the, minimizing the expected loss. So it's a bit tricky, but code is online if you want to look at it. Model training, validation, inference. Okay, so my final data set is really big. It's like 30 million rows with more than 100 columns. Trend validation split, you need to do a time split to avoid any leak, like Dan was explaining. Training, I'm using LightGBM. I'm not doing any hyperparameter training because I'm a bit lazy and because I'm bagging. I will explain this. I return on full data. Why? Because on time series, you have like concept drift or data drift. So retraining on the full data set provide a significant boost. Bagging, yes, I'm not trying to find the best model, but what I'm saying here is that maybe we can find 3 good models and we are going to average them. Averaging 3 models is better than finding the best one. That's the key idea. Yeah, I'm predicting from not the 31 December because otherwise you will have biased data of Christmas. So I was predicting before. If we look at the feature importance, what is really interesting here is that the most important features is the average sale for a given day of the week of the product on the last 64 weeks. And what is interesting here is that if we were not using machine learning, and we would like to use a really simple heuristics, is that we could simply use this variable and try to predict this, and we will have already a good model. But what machine learning is allowing here, us here, is that to weight smartly the different heuristic we have on the different features. I'm not, what I do is that I don't have a good, I have ideas. Maybe if it's a good idea or not a good bad idea, but I'm just feeding the model and I let the model infer what is useful or not, what isn't. And I don't have much time, so but yeah, I'm using Python. I'm using Git, MLflow for code experiment tracking, sample your data. If the full solution is available online on my GitHub, so you can have a look. And I'm already out of time, so I will stop here. But maybe people are questioning, are data science competition useful in real life? I think so. I think so for multiple reasons. I'm going to share slides, so if you want to have a look on this. And that's it for me.
Thank you so much, Jacques. Maybe to finish, I have myself two questions, and it resonates with what people are asking. How did you came up with a list of 120 features? And maybe the question is the same for everyone. And how do you avoid overfitting with such a long list of features? Now, I would like, before you answer that, just to give a hint for people listening to us. This data set is huge. And as you can see, Jacques had a machine with 300 gigabytes of RAM. So it's not a solution that you could run on most computers.
So how do I avoid features or overfitting? Actually, when you have you can regularize your algorithms, and I think it's better to add useless features than not adding good features. And at the end, I just give the model a lot of different features, and I let him choose: is it useful or is it not useful with regularization? And because if you want to remove useless features, okay, maybe it's going to provide a small boost, but it's also taking a lot of time to find useless features. And it's better to just let the model choose, is it useful or is it not useful? And not lose your engineering time, because actually your time is more valuable than your computer time. So that's the idea here.
Thank you. Maybe then another question for Florian, as you're like me, a consultant is dealing with business. We receive so often this question for business, like how do we deal with this black box? Because as we understood today, like these algorithms are kind of complex. For you, as you created them and you're an expert in that, it seems like you understand what you're doing. But for other people, it might be like, wow, this looks like really complicated. So how do you make sure that your client, the business people, managers that have business insight feel like they trust you and they trust the model?
Is the question for me or for Florian? Sorry.
For Florian.
Okay, sorry.
Thanks. This is a really hard question, and especially for us at Provision, because we offer an automated machine learning platform. So more than algorithm, we have a tool that create algorithm for people automatically. So the black box stuff is a real question, but again, it's not the good question. I mean, it's a question that comes from uneducated people, and our job as consultant is to educate them and to make understand that, again, algorithm relies on feature. Okay, so the way they use feature may be complex or not, depending on the nature of the algorithm. But I like to give this example. Why? Okay, this is a pen, but why is this a pen? And some tricky stuff happen into your brain. I mean, in fact, you take feature from it, it can write, you have a button and stuff like that. And for me, algorithm work the same way. When they take a decision, it's really difficult to understand the exact path, but we can explain decision. So it's out of the scope of this competition, but there is some algorithm and some method that exist that can tell you, okay, this project is going to be sold in 5 times next week because this feature equals this value and it has some previous, behavior. So explaining the decision and explaining why algorithms take decision are, in my opinion, way more important than explaining why the search tree in the random forest takes this or this kind of decision.
Perfect. Thank you, Florent. We'll try to finish in time. So for everyone, I will do my best to share with you the recording of this session, to share the slides, because I know that the number of attendees was limited. So I will share the video, the slides. You have the email of everyone. So if you have detailed questions, feel free to reach out to us. If we are not yet connected on LinkedIn, feel free to reach out to me. Dan, Florian, Jacques, Raphael, thank you again so much for your time, for the competition you did, your model, your passion and explanation. For most of you, thank you also so much for sharing the code and explaining everyone how you did that. It was a pleasure for me today to host this webinar, to share it with you. I hope everyone enjoyed it. So thank you so much, and then see you most likely in another competition.
Thanks, you guys.
Bye.
Thanks.
Thank you, Nicolas.